Hey students, this is a lecture on sketching graphs in cylindrical coordinates. Now, cylindrical coordinates show up a lot in physics and engineering applications, and the basic idea is instead of having a point of the form x, y, z, it's actually going to be in the form r, theta, z, where r is the radius in your xy plane, and then theta is the angle from the positive x-axis in your xy plane. So as you can see in this picture here, you still have your axes x, y, and z, but in the xy plane we actually are measuring using polar coordinates. R is the radius and theta is the angle, but z is still measured the usual way. So the reason they're called cylindrical coordinates is if you have something of the form r equals 5 or r equals whatever, that's going to give you a cylinder. In fact, in our first example, we're going to be graphing a cylinder in cylindrical coordinates. And remember, a cylinder kind of looks like a can of soda, right? That's what a cylinder is shaped like, without all the extra stuff on there. More like a can of Pringles, I guess. Okay, so anyway, let's see an example of this. Okay, so example. Sketch the graph in cylindrical coordinates. Okay, sketch the graph in cylindrical coordinates. All right, and for this first one, we're going to do the simplest type of graph. So example number 1, we're going to sketch the graph r equals 3. Okay, r equals 3. So now remember, r is actually the radius on the xy axis. Okay, so what's this going to look like? Well, we've got our x-axis, our y-axis, and our z-axis. And the standard way to sketch that is to have the x-axis coming out at you, and then the y-axis is horizontal, and then the z-axis is vertical. Okay, and then because the radius r equals 3, going back up to this picture, we can see that we're measuring a radius of 3, so that's going to actually give us a circle on the xy plane. Okay, so on the xy plane we have a circle of radius 3. Because, well, why is that? Well, all they give us is r, so r is fixed at 3, and then theta is not given, so that means theta goes in circles. All right? So anyway, if you have something in the form r equals a, where a is a real number, that's always going to be a cylinder where the base of the cylinder is that radius. Okay, so in the xy plane, we're going to have a circle of radius 3, a circle of radius 3, okay, and then that circle is just going to be the base of the cylinder, but the cylinder is going to go up and down. Because they don't tell us what z is, this is going to be a cylinder. Okay, so this is going to be a cylinder that goes up and down. And I'm going to make my drawing a little bit better here. Let me see if I can sketch it a little bit better. So in the back, I'm going to put dotted lines to show that it's actually in the back. So see how I put a dotted or dashed line back here? That's to show that it's behind the figure. So it's in the back. Okay, so let's zoom in on this a little bit so I can get a better picture. So the radius equals 3, and what we're dealing with here is, because the radius is 3, this is going to be a circle on the xy plane with radius 3. So for example, for y, this is 3, and then on the negative y-axis, this is going to be negative 3. Okay, and then the same thing on the x-axis. So the x-axis also goes from negative 3 to 3. So on the positive x-axis, this is 3. And then on the negative x-axis, back here, this is negative 3. Okay, and then z just goes up and down. But because they only told us what the radius was, it's actually going to give us a cylinder like this. Okay, and for this cylinder, the interesting thing about it is because they don't give us z, it goes up forever and it also goes down forever. So technically, to keep drawing it, I could draw it going all the way down here. Okay, so it goes forever down here and forever up here. I'm drawing little arrows just to show you what it looks like. But when you're looking at your homework on My Math Lab, they sketch it in a little bit different way. So they still have y, x, and z, but they have them arranged in a different way. So, so for your homework on My Math Lab, their sketch looks a little bit different. So it's still a cylinder that has a base of radius 3 in the xy plane, and up and down is still z. However, the way they sketch it, it looks a little bit different. So the way they do it is they actually draw a cube, okay? So they draw a cube. And how do you draw a cube? Well, fortunately, you won't actually have to sketch a cube on your homework. So you won't have to embarrass yourself like I am right now, because I'm clearly embarrassing myself trying to draw this. But anyway, that's just teacher problems. I probably should be using a graphing calculator, but I just felt like doing this one by hand, just so that you could see how to draw it by hand. Even though there are graphing utilities, it's fun to see things by hand sometimes. So anyway, what they do is they sketch a cube, okay? And in the cube, they put this cylinder where the base of the cylinder is radius 3. But the strange thing about it is they label this over here on the top as y. Okay, and then on the bottom down here, they label that as x. So it can look a little bit confusing. And then inside of the cylinder, inside of the cube, they put the cylinder. So they still have the same graph. It's just now inside of this cube, they're sketching their cylinder. Okay, so let me try to do that. Okay. So their graph is actually going to look something like this. And then they kind of shade it in. So I'll shade it in. So they shade in the top as one color. And then they shade in the sides to show that it's solid. So for me, I'm just going to go ahead and do a sketch of that. Okay, so when you're doing your homework on MyMathLab, assuming you're in my class and you're not just watching this video for fun, this is actually what our picture is going to look like, which is basically the same exact picture. It's just they have the y-axis labeled up here. So they have my graph rotated a bit, and then they have the x-axis going like this. But the middle is still going to be the same. It's just that the axes are rotated. But it's still going to have the same shape. So it's still going to be a cylinder with base, radius 3, and height z. That's really what we're sketching here in both of these pictures. And so how are you going to label the cube? Well, again, on MyMathLab, the way they label the cube is, let me zoom in. Because it's a cylinder of radius 3, they label the corners of the cube. So here's 3, here's -3 for the y-axis. And then for the x-axis, this is also -3 and 3. And then the z-axis is, of course, vertical. So here's the z-axis. But the only thing that's misleading about this is because they didn't give us z, this is going to keep going up, and it's also going to keep going down. But they seem to lose that in their picture on MyMathLab. So this is actually what their picture looks like. Okay, so again, the only difference from the way they do it in the book and on MyMathLab is they draw a cube like this, but they take the same picture and they put it in the cube. But fortunately, your homework is going to be multiple choice, so it's not going to be too difficult to choose the correct answer. You're not actually going to have to sketch it by hand like I did. Okay, cool. So that is the beginning of cylindrical coordinates. So just remember, in general, R equals A is a cylinder with circular base, with a circular base of radius A. Okay, so in general, R equals A is a cylinder with circular base of radius A, and then the height is Z, of course, but because Z goes up forever and down forever, you can't draw the whole cylinder, so you just do a sketch like what we did. So again, on MyMathLab, they just draw this little cube that includes part of the picture, but we know that this cylinder would actually keep going up and it would keep going down. Okay, cool. So that's the first type of graph that I wanted to talk about. All right, and then for problem number 2, we're going to see a different graph. So this is still in cylindrical coordinates, but for this one, we're going to do the graph z equals -3. Now, if you remember from just regular graphs, when we had x comma y comma z, the regular graph was actually going to be, if you had z equals something, it's a plane. And that's actually still true in cylindrical coordinates. Okay? So this is going to be a plane passing through z equals -3. So passing through -3 on the z-axis. Okay, and to sketch this should actually be pretty straightforward. So literally all we have to do is sketch a plane. And remember, a plane is a flat surface. Okay. Okay. So we've got our z is the vertical axis, and then the axis coming out at us is the x-axis, and then the horizontal axis is the y-axis. All right, and we want to sketch a plane passing through -3 on the z-axis. So just remember, z equals whatever is just going to be a flat plane. Okay, and this plane is actually going to be parallel to the xy plane. So if I go down here to z equals -3, then I can just, I'm going to sketch a plane that passes through -3 down here. All right, and it's difficult to draw for me because I'm not a very talented artist, but I'm going to try to sketch it anyway, just so you can see how people draw them by hand. Okay, so that is supposed to be a plane passing through -3 on the z-axis. That's actually a really bad drawing, so let me try to fix that up a little bit. Okay. All right, so the problem with my drawing that I did there is the perspective. So let me just redo it. I think you know what it's supposed to look like, but I didn't do a good job drawing it. So let's see, we want to have this side be parallel to the x-axis. And then we want to have, over here, we want this to be parallel to the y-axis. So there was a problem with the perspective that I was doing. But this should be a bit better. Okay. Okay, so here's the plane z equals -3. It's been a while since I've drawn one of these. And then on my math lab, once again, instead of drawing it the standard way, they actually draw a cube, and then they draw the plane inside of the cube. So I'm going to have fun drawing that. Okay, but this is supposed to be a plane passing through -3 on the z-axis, and the plane is actually parallel to the xy plane. Okay. My drawing is really bothering me. But I don't know what to do because I'm not an artist. So I'll just continue to suffer with my silly drawings. Okay, but remember that the plane goes all the way to infinity on both the x-axis and the y-axis, and it passes through -3 on the z-axis. So how do we draw this with a cube from my math lab? Well, from my math lab, or my lab math, whichever you prefer to call it, once again, you sketch a cube, and the cube just has a little portion of your drawing. So here I sketch a cube, and for the cube, we're going all the way to 6 and -6. Okay, so this is what it's going to look like on MyMathLab. Something like this. And of course mine doesn't look as much like a cube as I wanted, but that's okay. Okay. So mine looks more like a rectangular prism, but it's supposed to be a cube. And anyway, what we're doing here is because z equals -3, for whatever reason, they decide to go all the way up to, they go all the way from 0 to -6. I'm not sure why they do it that way, actually. But they start at 0 right here, and then this is -6. And that's for the x, okay? And then for the y, up here on the top left part of the cube, y goes from 0 to -6. And I really don't know why they chose these numbers, but I wanted to do it the same way they did so that you'll be good for your homework. Sometimes MyMathLab makes some strange choices about their graphs, okay? And then of course z is going to be the vertical axis. And for z, it's going from 0 to -6 as well. And I think the reason they did it this way, going from 0 to -6, is because on the z-axis, -3 is halfway between 0 and -6. So I think that's why they did it that way. And then for the x and the y-axes, they did the same thing because it's a cube. And a cube has to be the same length on each side. Okay, now this isn't a cube what I sketched because I'm terrible at drawing, but I think you get the idea. And then we just go ahead and we sketch a plane here in the middle. All right, because halfway between 0 and -6 is going to be our z equals -3. And of course they have that shaded in. So let me just shade it in with dashed lines. Okay. This must be really funny watching me try to draw this stuff in front of a camera alone in this room. Yeah, but anyway, that's my job right now. So, so what we got here is a plane passing through -3 on the z-axis, and this is the two ways of drawing it. Now this drawing on the left I'm not proud of, but the drawing on the right I'm more proud of, even though it's not a cube. I think it's a lot better drawing than this one. Okay. Wow, this is fun drawing this stuff. Okay. All right, so we're going to see one more type of equation, and this is going to be our last type of thing that you're going to need to sketch in cylindrical coordinates. Okay. Now, when I say you're going to need to sketch it, you don't really have to sketch it. I'm sketching them by hand. But if you don't want to sketch them by hand, you don't have to, because your homework, again, is multiple choice. So there will be 8 different pictures, and you choose the correct picture. So lucky you. You don't actually have to draw them by hand. But I'm figuring some of you may want to practice drawing them by hand. And I'm sure some of you can draw them better than I do. So that's why I'm actually taking the time to record this, or I'm drawing it myself. Okay, so we're going to see one more type of graph here. So number 3, example number 3, is r squared plus z squared equals 16. And this is still in cylindrical coordinates, okay? And this is the most complicated graph that we've seen. But if you remember some stuff from polar coordinates, that can help you here. So remember from trigonometry, pre-calculus, polar coordinates, remember that r squared is actually the same as x squared plus y squared. Okay, so that's the trick here. So r squared is actually x squared plus y squared. And again, that's from polar coordinates. And that's a topic that hopefully you remember from earlier courses. But if you don't remember it, you can brush up on it. Polar coordinates is basically all that's happening in these cylindrical drawings. So if you look back at the original sketch that we have here, which I obviously didn't draw because it's such a nice picture. Here we have r is the radius, theta is the angle, and that's in the xy plane. That's actually polar coordinates in the xy plane. Okay, so polar coordinates in the xy plane. Because instead of having it in the form x comma y, we have it in the form r comma theta. So again, theta is the angle measured from the positive x-axis, and then r is the radius of a circle. So that's why we know, hopefully we remember from another class, that x squared plus y squared equals r squared. Okay, so really our equation is going to be x squared plus y squared plus z squared equals 16. And instead of writing it as 16, I'm going to write it as the number squared that is 16. Because 4 squared is 16, and I want to have it in the form x squared plus y squared plus z squared equals, well, this is going to be confusing, the radius of a sphere squared. Okay? So hopefully some of you recognize this equation here. I believe we covered spheres earlier in this course, and hopefully you've seen them in other courses as well. But if we make this little substitution as polar coordinates, then we're going to end up with this formula, which is a sphere. This is a sphere of radius 4. So the whole reason I wrote 16 as 4 squared is so I'd be able to see what the radius is. And this sphere of radius 4 is going to be centered around the origin. So it's going to be centered around the very middle of our graph. Okay, so let me go ahead and embarrass myself again by trying to draw pictures. Okay, so first of all, I'll do a sketch. Actually, I think I'm going to try to draw the sphere first. Remember, a sphere is basically a ball. It's like, you know, the standard shape, like a basketball or a soccer ball. Those are spheres. Okay, or a bubble. Okay, so what's that going to look like? Well, it's hard for me to draw it, but here I go. Okay. So I'm trying to do a sketch of a sphere. So prepare to laugh at me. Okay, so let me zoom in on this, make it a little bit better. So it's supposed to look like a circle, but in 3D. So it's supposed to be, this part is supposed to be a circle, And the other part's supposed to also be a circle, but kind of sideways. There we go. That's probably about as good as I'm going to get. So if I zoom in on that, this sphere is supposed to be centered at the origin. Okay, so here we've got, out here is the y-axis. And then coming out at us is the x-axis. So that's probably a bit too steep. So the x-axis is coming out at us. So this is the x-axis. Okay, and then the last thing we have is, of course, the z-axis, which is the vertical axis in these pictures. And this is the standard way to draw it. This is not the way my math lab or my lab math draws it. But this is the standard way to sketch it. And because we said the radius was 4, we're going to be going all the way to 4 and all the way back to -4 on every single axis. So on the y-axis, up here on the x-axis, and back there on the x-axis, that's going from -4 to 4. And then up and down on the z-axis, the z-axis is going up to 4 and down to -4 as well. Okay, again, a terrible drawing, but you know, at least we got a little bit of humor out of this, seeing how bad I can draw these. And if I ever get to teach in person again, I'm going to get to draw these again on the board. So maybe if I get enough practice, I'll eventually not be so bad at them. Okay, but that is the basic sketch there. And then I wanted to do a sketch of the one on my math lab as well. Okay, but the way I drew it here is more the standard way that people draw it. And actually, I think I should draw the z-axis going all the way down here like that. Yeah, that looks better. Okay, so this is the standard way to draw them. And then what does it look like on my math lab? Well, once again, it's going to be the same shape. So it's going to be a sphere of radius 4. But they have it drawn within a cube once again. Okay, so I think you can guess what the cube is going to look like. So we're going to have a cube once again. I'm going to try to draw it more like a cube this time. So wish me luck. Oops. Okay, so awkward silence as the instructor tries again to draw a good picture, but he fails miserably. Actually, that one was a lot better than the other ones. Oh, I paid attention that time. It's not great, but it's getting there. Okay, so I'm trying to sketch a cube here. I'm about ready to give up on making it any better. And then in our cube, of course, we're going from -4 to 4 for the x-axis, the y-axis, and the z-axis. So labeling it the standard way my math lab does, they have, of course, back here we have dashed lines. Dashed lines. Okay, and then we're going from -4 to 4. So up here we have y, which goes from -4 to 4, and then z, is the vertical axis. That goes from -4 to 4. And then the x-axis is this one right here, which also goes from -4 to 4. And of course, those aren't actually the axes. The axes are in the middle, like in my drawing. But again, for whatever reason, this is how they draw them in my math lab. I'm not sure why they do it that way. But I want you to be prepared for your homework, so that's why I'm taking the time to painstakingly try to draw this by hand. Okay, so we're going to have a sphere. Let me see if I can draw a little bit better than that. Okay, so that's the horizontal part of the sphere, and then the vertical part of the sphere is going to go through the very middle up here, and the very middle of the square on the top and the bottom. Go up here, and then it's going to be going down there. Ooh, that's shaky. My hand got shaky for a minute there, and it just completely ruined the drawing. Oh dear, that's a terrible drawing. Let me make it a little bit bigger. Okay. Well, clearly I wasn't an art major. That much is clear. Whew, that's a pretty bad drawing, but you know, I'm just gonna call it quits on that one. Anyway, I think you get the idea. The main thing I wanted you to see was that it's a cube, and then we have a sphere on the inside. That's really supposed to be a circle right here. So that's why it doesn't look so great. It's because it doesn't look like a circle. I didn't draw that much of a circle. So let me try drawing a circle instead. See if that looks a little better. Okay, that's a little bit better. So now if you don't want to painstakingly draw them by hand, you don't have to. But that's what people used to do. And of course, it's easier to draw if you don't have shaky hands like me, but I do have shaky hands. This is how they have it sketched in my math lab. So that is a sphere of radius 4, and it's centered at the origin. Now, there are graphing utilities that you can use to help you with these. I don't know of a graphing utility that will accept it in this form, r² plus z² = 16. But a graphing utility I really like to use that's a 3D grapher is called Geogebra 3D. And this is assuming you don't want to try to sketch them by hand like I have been. Okay, so Geogebra 3D. Geogebra 3D is an excellent 3D graphing calculator. 3D graphing calculator. And of course, with my class, at least this semester, we're all online, so you can use this Geogebra 3D. So you just go to your web browser, and then you go to Geogebra 3D. Just type it into Google, and then it's the top hit, 3D calculator Geogebra. And then you're going to see on the top left corner here, you can enter in your equation. So for example, for the one we were just working on, our equation, if we try to do r² plus z² = 16, I'm not sure if it'll accept that. Let me see. Let me try that. It might accept it, but I don't think so. So r² plus z² = 16. See if it accepts that. No, see, it's not giving us a sphere. So that did not work. So I can't do it in that form. There probably is a way to do it in that form, but I'm not aware of it. So what we can do instead is just close this and redo it. If we do it in the form x y, and z, so in standard Cartesian coordinates, we can type in x squared plus y squared plus z squared equals 16. And there you have it. There's a much better drawing than what I drew. And you can actually drag this graph around. We can see that it's a sphere in 3D. So if you're taking a class or you're working in the real world and you want a really nice picture that you can drag around and look at, Geogebra 3D is the way to go. And then, you know, for the other two graphs that we did, you can also type them into Geogebra 3D, but you got to get them in the form where you have x, y, and z. Okay, it can't have an r or a theta. There's probably a way to do it with r and theta, but my understanding is that's going to be more complicated. So what I would do is, with my limited knowledge of GeoGebra, I would just go ahead and write these in the form where you have everything in terms of x, y, and z. So for example, for problem number 2, that was already, that one didn't have a theta and it didn't have an r. It was just z equals -3. So we also could have done that one on GeoGebra. So if I go back to GeoGebra and I delete this one, and then I type in z equals -3, z equals -3. I don't know what's going on with it right now. It's crashing. So I'm going to close it and reopen it. I don't know what I did to mess that up, but that happens sometimes. So you can just close it and reopen it if you're not getting rid of the other graph. So z equals -3. Z equals -3. Okay, so what's that look like? Well, unlike my terrible drawing, we can see this little blue thing down here. This is our plane, z equals -3. And it's a plane passing through -3 on the z-axis, and this plane is parallel to the xy plane. See, the plane in gray there is the xy plane. My only complaint about this is sometimes it's hard to know which one is the x-axis and which one is the y-axis. But I believe when it initially appears, it's sketched the way that we do, with the x-axis coming out at you and the y-axis being the horizontal axis. But let's see. I think the red one is the x-axis, but don't quote me on that one. And then the blue axis is always the z-axis. Okay, and then let's see. There was one more graph that we did. So number 1. How would we do that one in GeoGebra? Well, that one's a little bit harder to do in GeoGebra because it's in the form r equals something. So in order to use GeoGebra for r equals 3, we would have to convert this polar coordinates equation into rectangular coordinates, which is more difficult. So just the same way in problem number 3, we replaced r squared with x squared plus y squared, we're going to need to replace this r with something in terms of x and y. So how is that going to work? Well, you have to convert this polar equation to a rectangular equation. Okay, so GeoGebra for problem number 1. GeoGebra for problem number 1. We have to convert r equals 3 to an equation in x and y. To an equation in x and y. Okay, so how do you do that? You might be wondering. Probably the easiest way to do that is to just square both sides of the equation and then replace the r squared with x squared plus y squared. Okay, so I'm going to start with r equals 3, and then I'm going to square both sides. square both sides. And you're allowed to do the same thing to both sides of an equation. And one of those things you can do is to square both sides. So we're going to get r squared equals 3 squared. Okay, and then remember that r squared is the same as x squared plus y squared. Okay, so this is actually going to give us x squared plus y squared equals 3 squared. And you might be thinking, well, isn't that the equation of a circle of radius 3? And the answer is yes. But remember, this is actually x squared plus y squared equals 3 squared is a circle of radius 3, but because they don't give us z, z goes up and down, so that gives us a cylinder with base of radius 3, where z goes up to positive infinity and down to negative infinity. So this x squared plus y squared equals 3 squared is the equation of a cylinder with base of radius, so the base is a circle of radius 3. Okay, so we can go ahead and type this in to Geogebra, but we probably don't want to write it as 3 squared. So 3 squared is 9. So we're going to do x squared plus y squared equals 9. Okay, so if we go to our Geogebra, I'm going to close it and reopen it. That way I don't have the same problem as I did last time where I had 2 pictures on the same graph. Okay, so when I reopen it, I can go ahead and type in my x squared plus y squared equals 9. And as you can see, you have a cylinder, which this is the x-axis and that's the y-axis, I believe. So I was incorrect. The y-axis is actually the red one, I think. I'm not sure though. My biggest complaint about this is it doesn't say whether the red one is the x-axis or the y-axis. But you can drag this graph around. And then this is a cylinder. This is a cylinder with base of radius 3, centered at the origin, and the height of the cylinder is z, but z goes up forever and down forever. Okay? So that was a fairly embarrassing video for me to make because of my terrible drawing skills. And I fully expect to get some dislikes for this one, but that's okay. It probably was humorous to watch me trying to draw this. So maybe that at least was something about it. But as you can see, my terrible drawings by hand, you can still get the idea, but using a 3D graphing calculator like Geogebra is just much easier and much more helpful because you can drag the graph around and look at them. So I still feel like this was a good lecture, even though I have terrible drawing skills, because we learned how to sketch them by hand, which is tough, and then we also learned the modern way of dealing with these, which is to literally just type them in rectangular coordinates and then look at your graph in Geogebra. Okay, so thanks for watching.